The second section in chapter 2 talks about our mixtures. So we're going to talk about pure substances versus mixtures and how the mixtures can even be subcategorized into two parts. A mixture is exactly what it sounds like. It is a mix, a blend of two or more substances. As we all know, as Philly suburbanites, cheesesteaks are our way of life. You know, a cheesesteak is a mixture of cheese and steak and onions and bread. And when I tell my family from Poland about cheesesteaks, they're like, what? You put cheese on top of a steak on a plate? Ew. And I'm like, no, it's like chipped and it's like a whole big to do. Fruit salad is a mixture, steel, lemonade, all those different things. And they are definitely going to be subcategorized into two parts, a heterogeneous and a homogeneous mixture. Just like you saw in bio classes when you had heterogeneous alleles and homogeneous alleles. Okay, so hetero means different, so you're going to see different parts in that mixture, and homogeneous means that you're going to see the same. If we refer back to this classification of matter, how we have our pure substances and our mixtures, right? We're going to talk about these guys down here. We're going to talk about our homogeneous mixtures and our heterogeneous mixtures. Okay, so again, chemistry is the study of matter and the changes they undergo. So we have to look and see how mixtures behave. Well, it depends on the type of mixture. If it's like a saltwater solution or tap water or alcohol, that will behave one way, whereas a heterogeneous mixture is going to behave another. So, like I said, you're going to see this little graphic organizer a couple more times. All right, so heterogeneous mixtures are not uniform. If we wore uniforms to school, we would all be exactly the same, have the same tops, have the same bottoms. But hetero is not uniform. Okay, in terms of comparison, they are relatively easy to separate. If you order a salad and you don't like cucumbers, you can take the cucumbers off. Or if you don't like the tomatoes, you can take your tomatoes off. If you order a cheesesteak and you don't really like the fried onions, it's a pain, but you can get the fried onions off. If you order pizza and you don't like the pepperoni, bye bye pepperoni. All right, but homogeneous is uniform, and that's going to be a lot more difficult to separate. Not impossible, but it's going to be difficult. Okay, salt water, you can remove the salt from a water. Remember, solubility is a physical characteristic. Okay, it's a pain in the butt, but yeah, you can do it. Um, Soda, if you get soda and you go to a restaurant or, if all they have is orange soda, you can't really take the orange out of the soda. It's not impossible. You could do it in a lab, but you can't do it at the restaurant like you could take, your pepperoni off a pizza. Iced tea, if you don't like the flavor of the iced tea, it's hard to separate. You can't really do that. Brass, that's going to be your copper and zinc that come together to make that nice little fake golden color, um, which is going to be used for keys and doorknobs and hinges and stuff like that. All of those homogeneous mixtures are called solutions. Solutions are not just liquids. All right, they can be solutions of air. All right, we have our air. We can filter our air so that it doesn't have bad stuff in it. You can have a solution of metal, okay, like I said, the brass. So you can have solid and liquid and gaseous solutions. So I like really pointing out that, just what we know in common everyday life is in everything that we have in chemistry. If you want to separate a mixture, you use physical properties to separate them, separate the components. So again, a physical property can be changed or can be observed without changing what the substance is. So like if you have a mixture of iron filings and sulfur, oh, it's awful to try to separate it by color, but one is magnetic, the iron, and the sulfur is not magnetic, so you can easily take those away. If you have two liquids that are dissolved together, you can evaporate it. One can come up and the other could stays behind. You can undergo distillation. All right, we know some common things that are distilled are going to be your vinegar, uh, water, and your alcohols. And what that means is you're using the characteristic liquid boiling point in order to separate them. And then when it's boiled, since boiling point is a physical property, it's condensed right in the next step in order to make your liquid again. So a little setup that I do in class is a distillation apparatus. If you have my notes, you can click on the link here to see a simple distillation apparatus. But what I generally put in my flask over here is going to be grape Kool-Aid. All right, and grape Kool-Aid is going to be purple. It is going to be heated by our Bunsen burner, and it's going to be in this little bent arm flask, which is going to trap all of the vapors inside, and the thermometer tells you what temperature it's boiling at. So water boils at 100 degrees Celsius. So what happens to those trapped vapors? They go down the side arm right here. They go through this special condenser, and a condenser is a tube within a tube. It has a cool water intake that you hook up to your sink and a water outlet so that it's constantly recycling cool water. And what it does is if you have your steam right here traveling through, so your steam is here, well, when the steam comes in contact with something cool, it's going to condense, as the name suggests, a condenser, and it's going to drip out in the liquid form here. And this is when it's already distilled, it's called a distillate. So this is what you are distilling, and this is your distillate. So this flask at the other end is going to take from a liquid to a gas to a liquid again. Okay, in this nice reversible reaction. And the cool part about Kool-Aid is that when this boils off and comes through, you end up getting clear water at this end, and you get the odor, the grape odor, but it doesn't taste like grape. All right. So what would be left in this distillation flask when you're done? That's going to be your powdered Kool-Aid, which is basically sugar and citric acid, depending on if you get the little packets or if you get the one with the sugar already mixed in it. All right, so you can evaporate all of these liquid particles and leave the solid Kool-Aid part behind. You can undo some sort of mixture. And that's the beauty of chemistry. Okay? Mass, matter, changes that they undergo. And that's what we're going to be looking at this whole year.